Hi, and welcome to the first video in this series on coronary heart disease. In this video, we'll go through the basics of what coronary arteries are, where they are, and why they are important. We'll also be taking a look at the cellular structure of a healthy coronary artery. This will help you understand what an unhealthy coronary artery looks like in VDS2 and VDS3. Okay, so what is a coronary artery? To find out, it might help us to take a look at the word coronary. Taking the word apart, we find that the stem of the word is corona. That's right, the same corona as the corona in coronavirus, and for those of you who like having the occasional beer, the corona beer. But what do these coronas have anything to do with coronary arteries? Well, the word corona comes from the Greek word korone, referring to a crown, wreath, or halo. This probably explains why the logo of the Corona beer is a golden crown, and is actually the reason why the microbiologists who discovered the first coronavirus named it the coronavirus. Looking down the microscope, they saw the big round body of the virus with a halo of bumps surrounding it, hence the name coronavirus. In a similar way, coronary arteries are arteries which surround the heart like a crown. Here on the left-hand side, you can see how the coronary arteries are surrounding the heart, and on the right-hand side, artist Ashley Davidov's impression of the coronary arteries. In her artwork, she isolates the coronary arteries, flips them upside down, and colors them gold, truly showcasing why they are named coronary arteries. Now you might be asking, why are these arteries shaped like a crown, and what do they do? Well, it turns out that the answers to these questions are closely linked. As you may know, the heart is responsible for pumping blood to our organs, ensuring that they get the oxygen and nutrients they need to survive. This is done 24/7 by the muscles in our heart. But what you might not know is that these muscles need a blood supply of their own. This is what our coronary arteries do. They supply blood to the muscles of our heart. Because there's muscle all over the heart, the coronary arteries must loop, bend, and curve to get to every inch of muscle. Let's take a closer look at this on our 3D mesh mixer model. Here you can see that the coronary arteries begin their journey at the base of the aorta. The aorta is the largest vessel coming off the heart and is responsible for pumping oxygen-rich blood to the rest of the body. But before this blood gets to the rest of the body, a small amount will go through these coronary arteries. Following this coronary artery, we see that it loops around to reach the muscles on the sides and back of the heart. If we come back to the front here, we can see that another branch continues straight down to supply the muscles in front of the heart. Looking at the other side of the heart, we can appreciate how the coronary arteries follow a similar path around the sides and back of the heart. If we turn the heart transparent, we can appreciate the full extent of these coronary arteries. Now, let's move on to the cellular structure of a coronary artery. What you can see in front of you is a histological slide of a coronary artery. In other words, it's a very thin slice of tissue that someone has cut from a coronary artery, as if they were thinly slicing a carrot. After the slice is made, it is washed in special chemicals that stain different cells in the walls of the artery with different colors. This allows us to come in with a microscope and appreciate the beautiful layers that make up the walls of the coronary artery. Coronary arteries, like other types of arteries, will have three distinct layers of cells making up the wall. The innermost layer is named the tunica intima, and is made up of small, flat cells named endothelial cells. In coronary arteries, these endothelial cells are joined very tightly together to prevent any blood from the inside of the artery from leaking out, and any foreign bodies outside the artery from making its way into the bloodstream. The next layer of cells is named the tunica media because it's in the middle. This layer is mostly made up of smooth muscle cells. Smooth muscle cells contract and relax to make the diameter of the artery bigger and smaller. This allows your body to change the flow of blood depending on how hard the muscles of your heart are pumping. For example, your heart muscles are working much harder during exercise than when you are at rest. To respond to this increased workload, the smooth muscle cells in the tunica media of your coronary arteries will relax. This causes the diameter of the coronary artery to increase and allows more blood to flow into your heart muscles. As you will learn in video 2, the tunica media is also the layer where fat builds up and constricts the coronary artery during atherosclerosis. The final outermost layer is the tunica adventitia, which is made mostly of connective tissue. As the name suggests, connective tissue simply connects the coronary artery to the surrounding muscle of the heart, and it is mostly made up of fat. Connective tissue also has a protective role, as it shields the tunica media and tunica intima underneath from external impacts.